So, alright. Come on. Okay, today we're talking about something called reference angles. So the first quadrant angle, let's say, is 30 degrees. It would give you the same result as an angle that's 30 degrees off of 180. So this really wouldn't be a 30-degree angle though, guys. It's going to start. It would be, because remember we're starting from here. This would actually be 180 minus 30, so this would be, whoops. So this would be like 150 degree angle. That would be theta on this one. So 150 degree angle will give you the same result as a 30 degree angle if you use sine or cosine, is what I'm talking about. Because it has the same ratios here. Like the rise and the run are the same as the rise and the run here. Like the y value, the x value. The opposite over the adjacent, they're the same thing. So if I plug in sine of 30 in the calculator, it'll be the same thing as if I plug in sine of 150. Okay, they'll give you the exact same value, whatever it is. If I plug in cosine of 30 and cosine of 150, they won't give you quite the same thing. They'll actually give you the opposite thing. 30 degrees, this actually makes a special triangle. Do you guys remember this one? 1 to 2 square root of 3. So we could like specifically figure out what it is in this case. So the difference is on this one, the x value is more like a negative square root of 3, and this is like a positive square root of 3. So cosine of 30 would be adjacent over hypotenuse. Now if you plug this in your calculator, it might just give you a decimal. Some of your calculators are smart enough, it'll spit that out. But cosine of 150, though, would be adjacent negative square root of 3 over 2. So they're not exactly the same. They're just one's positive, one's negative. But these two would be exactly the same. Do you guys know why? These are both 1/2. Because it's based on the y value. Sine is based on the y value. And y is positive in the first and second quadrant. However, if we went to the third quadrant, okay, the reference angle in the third quadrant would be 30 degrees. It's still 30 degrees off the 180, but it's 30 degrees past 180. So it would be like 210. Well, from here all the way around, it would be 210. So if you plug in sine of 210, you guys know what you get? You get negative 1/2 because sine is negative down here. And the fourth quadrant angle, it would be 30 degrees off of 360, which would be 330, all the way around there. And if you plug in sine of 330, you would also get negative 1/2. Okay, so if I plugged in cosine of 210, cosine is based on x, so it's cosine is negative here and here, second and third quadrant. So it would also be same as that one. And if I plugged in cosine of 330, it would be positive because in the fourth quadrant, cosine is positive. Okay, so all of these angles, 150, 210, 330, have 30 degrees as the reference angle. So they kind of all equal the same thing because they make the same ratio, except for sometimes they're negative and sometimes they're positive. So let's remind ourselves, when was sine positive? First and second. Basically, based on the y value, so it's positive up here. Y is positive up here. And then cosine, whoops, is based on the x value. So where is that positive? 1 for n. And so it'll be kind of like a lot of repetition, kind of like the last assignment. We are doing a little bit with special triangles today. So do you guys remember the 45, 45, 90? The legs, I don't know if I drew it very well, but the legs are the same on this one. So it's 1 to 1. The hypotenuse, if you forget, you could like do Pythagorean theorem, but square root of 2. That doesn't mean that's how long they necessarily are, that just tells you the ratio. So it might, their actual length might be like 5 and 5 and 5 times square root of 2. That's like an example. And the 30, 60, 90 I kind of just did up there, but the short leg is 1, hypotenuse is twice as big as that, and the leg is square root of 3. So an actual example, like if this was 5, this would be 5 times 2, 10. This would be 5 times square root of 3. It's all coming back to you now? Sure. Alright, let's see, how big should I make this? You guys see that? Okay, numero uno. Okay, actually let me talk about that. Let me back up for a second. So what I said was the first quadrant angle is going to be give you the same result as the second quadrant angle. Second quadrant angle is basically going to be 180 minus theta. And then for the third quadrant reference angle, it's going to be 180 plus theta. And for the fourth quadrant angle, it's going to be 360 minus theta. Alright, so on number 1A, express each of the following in terms of the reference angle. So sine of 128 is going to equal. All right, what quadrant is sine of 128 in? Second quadrant. I don't like my drawing here. There, that's better. Second quadrant. So to find the second reference angle in the second quadrant, you basically do 180 minus the angle, and that'll tell you like how big the theta is, the reference angle is. So 180 minus 128 is 52. So is sine going to be positive or negative in the second quadrant? Positive. So it's going to be positive sine of 52 degrees. Does that make sense? Kind of. If you plug these two things in the calculator, they'll give you the same answer. That's kind of what we're saying here. All right, and then cosine of 128, it's going to equal cosine of, we kind of already did it, cosine of 52 degrees but is cosine positive or negative in the second quadrant? Negative. So I should put like a negative on that one. C, negative 30, sine of negative 37. What quadrant is negative 37 degrees in? The fourth. So if they tell you negative 37, that would be like from here to here. That is the reference. Well, 37 would be the reference angle. But is sine positive or negative in the fourth quadrant? It's negative. And D is cosine of 500. What quadrant is 500 degrees in? Okay, well, if you take away 360, 500 minus 360, you get 140. So it's going to be the same as cosine of 140. So cosine of 140 would be in the second quadrant. And how far is 140 from 180? It's 40. So this is going to equal cosine of 40 degrees. Is cosine positive or negative in the second quadrant? Negative. Okay. What quadrant is 224.5 in? Third. So to find out like what this reference angle is here, we need to figure out how far this is from 180. So 224 minus 180 would give us 44.5. So this is, and is cosine positive or negative in the third quadrant? So it's negative cosine cosine 658. Okay, 658, if we unwind that one revolution, minus 360. So if it was 660, it would have been 300, so it's like 298. What quadrant would 298 be in? Somewhere in there, yeah, fourth quadrant. So to find out what theta is, if we do 360 minus 298, that'll tell us the gap between that and 360. Be 62. Is cosine positive or negative in the fourth quadrant? Positive. C, sine of 145. Okay, what quadrant is 145 in? Short of 180, right? So it's somewhere between 90 and 180, somewhere over here. To find out how far it is from 180, you just do 180 minus that. I believe that'd be 34.3. And is sine positive or negative in the second quadrant? Positive. Where is negative 201? Well, we're going backwards, so yeah. It's past negative 180, so it'll be somewhere right in there. So you just need to figure out how far past 180 it is. So you can just do 201 minus 180, which is 21. So it'll equal sine of 21. Now we're in the second quadrant. Is that going to be positive or negative for sine? Positive. Okay. Well, number 5. This will be my Thanksgiving gift to you guys. So, but I need to warn you a little bit. It just says use a calculator to find the value to 4 decimal places. So you can just plug it in. Round it to the 4th decimal place. I will be mean on the rounding though, so round it correctly. What's up with D on number 5? Okay, it just says sine of 0.49. It does not have the degree symbol. So what do we do about that? Okay, if it doesn't put degrees, it means radians. And remember, you guys remember how to change your calculator to radians? They're all probably a little bit different, so I'd have to come look, but somewhere in the setup or something, you have to find the radians. But remember, after you push radians and you start doing the next problem, you got to change it back to degrees again. So actually, for 5A, you might want to make sure it's in degrees right now. Let's everybody plug in sine of 28. Let's see if we're all in degrees or not. Should be 0.4695. A lot of calculators put a little DEG up top to say you're in degrees. Some of them do. Or RAD if you're in radians. Anyway, don't forget to switch it once you get to D to radians. The next weird thing is 7D. And 8D has one also. I think we talked about this once. You guys know what's happening on 7D? Huh? Minutes, which means what?
1860.
Right. Right. So you'll want to plug in sine of 207 and 1860 is probably calculator like a mixed number. Calculator will probably let you do that. There's also something called seconds, which would be a 60th of a minute, but they're not quite that mean to us. Anyways. Feeling ambitious with this assignment. 1 through 16. Okay. Can you guys just leave space and I'll talk about number 11 now. Okay, what's special about these? Study the sine and cosine values of blah, 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 blah. Then give the exact value of each expression in simplest radical form. So, I don't know. How good's your guys' vision? Can you guys see that? So it's using special triangles, special angles. There is a table they're referencing on page 277. So you kind of need to have the special triangles memorized though. So anyway, it might be better to look at the triangles. Okay, give the exact value for each expression. Cosine of 45. So, do you guys remember that cosine was like SOHCAHTOA, right? I guess we'll put an A angle. Alright, so cosine of 45 would be adjacent over hypotenuse. The adjacent is 5, the hypotenuse is square root of 2. Problem is, you're not supposed to leave a square root of 2 on the bottom. So you multiply top and bottom by 5 square root of 2. Or let your calculator do it, or whatever. Anyway, is cosine positive or negative in the first quadrant? Positive. So, that's it. Some of your calculators might be able to do this. So, if they can, I guess I'll just let it go. Some of yours probably can't. Or you might have to have it in the right setup for it to work. Okay, on B, cosine of 35. 135 is 45 degrees off of 180. So it's going to have the same reference angle of 45 degrees. So A and B are going to be the same answer. Except for, is cosine positive or negative in the second quadrant? Negative. So it's just negative that. Okay, for C, sine of 210. 210 is third quadrant, is 30 degrees past 180. So it's going to give us the same answer as sine of 30 degrees. Sine is opposite over hypotenuse. There's 30. Opposite over hypotenuse is 1/2. Is sine positive or negative in the third quadrant? Negative. It might be going too fast. Okay, anyway, D, cosine 150. 150 is 30 degrees. It's in the second quadrant. It's 30 degrees short of 180. So it'll be the same thing as cosine of 30. Cosine is adjacent, square root of 3 over hypotenuse 2. Is cosine positive or negative in the second quadrant? Alright, does that kind of make sense? I probably went too fast. Did you guys already try it with your calculator to see if it worked? If you get a decimal, we can't use that. We need the exact answer, the square root answer. I mean, if the answer is like negative 1/2, negative 0.5, that would be exact. I don't know why I put that. Okay, sine of 150. So that's going to be the same thing as sine of 30, because it's 30 degrees short of 180. Sine is opposite 1 over hypotenuse 2. Is sine positive or negative in the second quadrant? Positive. Did I get one wrong?
No, it works in the calculator, it just doesn't give us the right thing. Like, cosine of 45 gives you square root of 2 over 2.
Oh, maybe I did the wrong. Oh, I put a 5. Get out of there. No, I did the wrong thing. I only did it on that first one. Okay, cosine is, 1 over square root of 2. My bad. Alright. My brain wasn't turned on, I looked at the 5. So it's, multiply top and bottom by square root of 2, it's square root of 2 over 2. negative 240. So negative 240 goes backwards into the second quadrant, and it's 60 degrees past 180. So it'll be the same thing as cosine of 60. But it's in the second quadrant. So cosine of 60 is adjacent over hypotenuse. So it's 1 over 2 again, but in the second quadrant, cosine is negative. C, sine of 135. We talked about this on 11b, but sine of negative 135 would go backwards into the third quadrant, but it's 45 degrees short of 180, so the reference angle is 45. And let's see, what was it? Sine, sine. So sine is opposite over hypotenuse, 1 over square root of 2. So it's square root of 2 over 2 again. Is sine positive or negative in the third quadrant? Negative. And then D, it's negative 30. So negative 30, so the reference angle is 30 because it's 30 degrees off of 0 or 30 in the fourth quadrant. So we need to do cosine of 30, which is adjacent over hypotenuse, so square root of 3 over 2. Is cosine positive or negative in the fourth quadrant? Positive, so what's that? Why didn't I put cosine? This is the Earth. Beautiful. What are the coordinates we use to find location on the Earth? What are the coordinates we use to find location on the Earth? Called longitude and latitude. Do you guys recall what the I don't know if I can draw another one that's decent. What these lines are called? Horizontal. No. It's called latitude. Cause I just remember because it reminds me of a ladder. But so these lines of latitude, you guys probably looked at this like in geography or something, but it'll say like 20 degrees south or something like that. And that's kind of like based off the equator. It's like from the center of the Earth down, it's down 20 degrees. Okay, so the South Pole would be 90 degrees south, like going straight south. Anyways, and then you have 10 degrees north, 20 degrees north, 30 degrees north, and all the way up to 90 degrees north. It says latitude of Lima, Peru is 12 degrees south. About how far from Lima is the South Pole? should have read the directions. In the directions it says, use 3,963 miles for the radius of the Earth. 963, right? Okay, actually I'm kinda confused why they put this one in this assignment, because it seems like it would have gone better with the. That's Mr. Cloud's phone. Did you hear it? Star Wars. Dun, 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 dun. And he's like, hello. So, we're trying to find out how far it is from here to here. How would we figure that out? What is this? Arc length. What would the angle be from there to there? Okay, it's 12, Lima is 12 degrees south, that's what this 12 is there for. So yeah, from Lima down to the South Pole, that would be 78 degrees. Because they have to add up to 90. And it says the radius is 3963, so arc length degrees, theta pi r over 180. Basically, it's the circumference formula times pi over 360 is how we got this. But so that goes right there. 78 degrees goes right there. I wonder if the book did it differently, because I'm a little bit confused at why they did this. Of course, they don't tell me how they did it. I'll just. Yeah, let's just do 28. Not 29. I don't know what I was thinking exactly there with the 3 problems, but let's just do 28 for this. Pretty close to the same thing as what we just did. You have to subtract the degrees to find the theta. How far apart those things are. Did anybody plug 27 in yet?
Do you want a decimal form?
They rounded to the nearest mile, so.
5,395.